Hello everyone, my name is Wladymir Brborich. Thank you for joining me here. I am very happy to have the opportunity to present the investigation I've worked on, an observational study on the maintainability characteristics of the procedural and object-oriented programming paradigms. So what is the motivation behind this? In the software industry, there has been this great push for clean and maintainable code, including the promotions of good practices, design patterns, guidelines, and more. Nonetheless, we found that there was a lack of recent comparisons between programming paradigms. Therefore, we wanted to take an initial step and lay some groundwork on answering the question of how the selection of programming paradigm affects the maintainability of a software system. Answers to these questions are important because they can provide insight on how the maintainability characteristics could be leveraged to improve the software engineering education. In this research, we compared the two most common imperative programming paradigms currently in use today, procedural and object-oriented. Our comparison method differs from others in that it uses an experiment to measure developer speed and effectiveness as the means to identify differences between the paradigms. Our contribution comes from the lessons learned while performing this investigation and of the insights the results provide. However, before we can discuss the results of the experiment, we need to be clear on some background concepts and the method used, starting with programming paradigms. A programming paradigm is a way of thinking about, designing, and implementing software. It is more general than a programming language as it identifies concepts or abstractions that the programmer might use to solve problems. Educators have long debated the choice of programming paradigms for computer science curricula, directly in terms of which contains the most important concepts, and indirectly in terms of the best programming languages for their classes. However, rarely has this debate included the discussion points about how a given programming paradigm can affect the maintainability of software and therefore influence the education of software engineering students. Which brings us to maintainability. We understand maintainability as the ease with which software can be modified to correct failures, increase performance, or adapt to different conditions. Therefore, teaching students to perform maintenance tasks effectively and efficiently should be a critical component in a software engineering educational program. This brings us back to the choice of programming paradigms. Which paradigm could be the best for teaching students to create more maintainable software? Or, more importantly, how does a given paradigm impact what students learn about maintenance? Unfortunately, answers to these high-level questions depend on answers to more fundamental questions, like are there any difference on maintainability characteristics among programming paradigms? As an initial step towards answering this question, we present an observational study that compares the effectiveness and speed with which students, can complete a set of maintenance tasks on functionally equivalent programs developed with procedural and object-oriented programming. We based our study on the method presented by María Genero in her book Métodos de Investigación en Ingeniería de Software, which describes the process to define, execute, gather, and interpret data from an experiment in a software engineering context. The main goal of this study is to compare the maintainability of two variations of a program, each implemented using a different programming paradigm, namely procedural and object-oriented programming. The context consists of our experimental object, which is the software implemented in both programming paradigms, and the subjects who participated on the experiment, namely software and systems engineering students. The independent variable in this case is the selection of programming paradigm, whereas the dependent variable is the maintainability measured using two metrics, maintenance effectiveness, ME, and maintenance speed, MS. To measure MS and ME, we also define treatments in terms of maintenance tasks. A maintenance task is defined as the description of a functional requirement of the system, its expected operation, and its current malfunction. In other words, a maintenance task relates to a software error that the developer must fix. I will explain the aforementioned treatments with the experiment design later. We formulated and tested the hypotheses shown in this slide. The hypotheses are described in terms of our metrics MS and ME, which are related to the maintainability characteristics of a programming paradigm. The goal is to reject the null hypothesis, which state that both programming paradigms have equal maintainability characteristics, and possibly accept the alternative ones. According to the values of the independent variable, we define the following treatments. T1, execute for the procedural software a set of maintenance tasks, and T2, execute for the object-oriented software the same set of maintenance tasks. We also divided the subjects into three groups, G1, G2, and G3. For G1 and G2, we used an intra-subject design. Both groups were divided into two subgroups of approximately the same size. Each assigned a different treatment, and both subgroups performed all treatments. For G3, we used an inter-subject design. The group was randomly separated into two subgroups which performed a different treatment each. For this research, we developed a set of instruments consisting of two versions of the same software, each implemented in a different paradigm, 5 maintenance tasks, each representing a different kind of software error, a suite of unit tests to check the correctness of each task, a GitHub repository for each group, and finally, 3 surveys to be applied before training, after training, and after the experiment's execution. In preparation for the experiment, 2 weeks before the execution, we conducted training sessions, so all subjects have a similar level of understanding of the tools and necessary concepts. In addition, to calibrate the total time required to perform all maintenance tasks and fix any issue with the materials, we conducted a pilot experiment with students who were not part of the subject group. For the experiment execution, the subjects were first given the necessary resources to perform the maintenance tasks, i.e., access to their group's GitHub repository. Every subject received the following instructions. 1. Run the web application locally on an assigned development machine. 2. Record the start time and begin working on a maintenance task according to its description. And 3. When a task is completed, inform one of the instructors. To avoid possible bias in the results, the hypotheses under study were not reported to the subjects. After the experiment execution, we did a descriptive study for the statistical data of the surveys and the measures of MA and MS as follows. A for both values of the independent variable, B for the entire sample, and C grouped by gender, age segment, course, and treatment order. In this presentation, however, we are only going to include a few highlights. The following graph shows the general average for the survey results for the subjects' perceived knowledge before and after the training session. We observed that, on average, subjects increased their perceived knowledge, which points to a successful training session. In addition, we noticed that subjects from the more junior semesters were the ones that have the biggest differences before and after training, whereas more senior students have the greatest averages before training, which is in line with what we expected from the group selection. Statistical analysis shows that subjects performing maintenance with procedural programming were on average 8.33% more effective and approximately 1 task per hour faster than those performing maintenance on object-oriented programming. To test the formulated hypothesis, we analyzed the effect of the independent variable using statistical tests depending on the data distribution. For each case, for ME, we used the Wilkinson non-parametric test, since its data distribution was not normal. For MS, we used a t-test, since its data distribution was normal. In both cases, the results show that we can reject the null hypothesis, since we have a p-value smaller than 0.05, indicating that there is a difference between the maintainability characteristics of procedural and object-oriented programming. These results seem counterintuitive, given that most experts support the claim that object-oriented programming provides overall better maintainability characteristics than procedural programming. I will address some possible explanations in the next slide. So now that we have seen the results, we can move on to a discussion phase. So first, in the context of the sample population and experimental object, there is a difference in maintenance characteristics of procedural and object-oriented programming. Second, the experimental method proved to be sufficient and could serve as a valuable starting point for future experimental designs. The statistical data presented might lead one to conclude that procedural programming has better maintainability characteristics than object-oriented programming. However, ranking the maintainability characteristics of the paradigms was not a goal of this study. There are several reasons why this study produced the results that it did, and that can provide insights into how the experimental method could be improved. So, one of the reasons is that the study was intentionally limited. The experimental object is representative of only one type of software and system architecture. The set of maintenance tasks needs to be larger and more representative. The experimental object also needs to be validated by a third party. This means that we cannot generalize the results of this initial study to a broader context. Nevertheless, there is enough evidence regarding differences among maintainability characteristics of different programming paradigms to warrant further research in an attempt to build an accurate classification of the strengths and weaknesses of each one. With the results of this study, which include preliminary evidence that there is a difference in maintainability characteristics of procedural programming and object-oriented programming, we encourage further investigation into the maintainability characteristics of programming paradigms. In particular, with respect to how software engineering educational programs can leverage these differences. Other important contributions include a prototype of an experimental method that can be adapted for future experiments and insights about how to strengthen those experiments with more diverse experimental objects and maintenance tasks. Thank you for listening to me. This has been an honor. Please have a good day.